Hi everyone, in this video we would be designing the movie booking application which is asked in top product based companies. But if you want to design the flight booking system or hotel booking system, then also this video would be very helpful for you. So let's get started. So let's understand the system. Before checking out this diagram, let's first check the BookMyShow website itself. So currently I am onto the BookMyShow website where I would be showcasing you how to book a ticket. So firstly, you will select the movies, and here you would be having the list of movies available in your city, right? So let's say I want to watch this Jurassic Park. So I'll be clicking on this movie and I'll be clicking on this book tickets. So once we click on this movie, we would be having the list of shows for that movie. So over here we have the theaters where this movie would be screened, and in that theater these are the shows, right? So one show is at 12:20 p.m, another is at 5:50 p.m, and so on and so forth. Okay, so the point that I want to highlight over here is our application should be able to display all the shows for the movie which user has selected. So this is the first thing which this BookMyShow application supports, right? Now coming back to the diagram, once I am sure for a specific show, I would click on that show, and there I would be prompted to select some seats which I want. Now the light gray colored seats which you are able to see over here are the regular seats, and this dark gray colored seats are the premium seats. Okay, and the red colored boxes which you are able to see over here are the booked seats. So someone has already booked this 5 seats, right? And this is the green colored box, which means that I have currently selected this seat. Okay, so once I select some seats, I would be clicking on this proceed button so that I can pay for that seat, right? So once I click on this proceed button, this particular seat which I have selected would be locked. So no other user can select that seat. If that user tries to select that seat, then one error message would be displayed indicating that that particular seat is temporarily unavailable. Okay, and after clicking on this proceed button, you would be on the payment page like this. You would be selecting some payment option like GPay, card, PayPal, etc, and you have to pay for those seats which you have selected. But the point that I want to highlight is you have to pay within the TTL. So the TTL for BookMyShow is 8 minutes. After 8 minutes, the lock which is on this seat would be automatically released so that other users can lock that seat. Okay, right? So within 8 minutes, if I pay for the seat, well and good. If I am not able to pay within 8 minutes, I have to go back over here and reselect that seat. Okay, so after 8 minutes, even if I click on the pay button, it would be showing one error message that the seats are not locked or the lock is not owned by you. So it will automatically throw you on this particular page where you have to select the seats. So I hope you have understood the entire BookMyShow system. Now let's try to gather the requirements. These are the requirements. I have categorized the requirements into 3 parts. The first one is extensible, second one is dynamic, and the third one is high traffic or the concurrency. So let's check out the extensible category first. So in this category, these are the questions which you can ask the interviewer. The first question is, what are the types of seat available in our system? So let's say the interviewer says, currently there are 2 types of seats. First is regular and second is recliner. But our system should be able to support different types of seats in future as well. That is premium, VIP, etc. So this indicates that the seat should be extensible. In future, I should be able to add more and more seats without modifying the old code. Okay. The second point you can ask the interviewer is, what payment methods are currently supported in our system? Again, the interviewer says that currently UPI and the card payments are supported, but in future we should be able to add more payment methods. So again, this is telling us to make our system extensible for the payment component. All right. Now coming to the dynamic category. By dynamic category, I mean that the end user or the admin should be able to perform certain operations. By operations, I mean we should be able to add theaters, screen, seat, movie, and shows into our system. And there is one more operation that the end user can perform is they should be able to get all the shows by the movie name. Okay. So these are the 6 different requirements in the dynamic category. Again, by dynamic, I mean that the end users or the admin should be able to perform some operations. Okay. Now coming to the high traffic or the concurrency requirement. So over here, the first question that you can ask the interviewer is regarding the thread safety. So let's say there is one seat and 2 different users who are trying to select that seat. So obviously only one of them should be getting that seat, right? And the interviewer says that yes, you have to handle that. Okay. Now the second question that you can ask the interviewer is, should the failed payments or the expired locks free the seat for others to book immediately or not? So again, the interviewer says that yes, after some time duration, the locks on the seat should be automatically removed so that other users can lock that seat, right? Because as the owner of the theater, I want to maximize the profit, right? So if user 1 has selected the seat and he is not paying the bill, then obviously I want to unlock those seats, right? After some time duration. So that's the key requirement over here. After some time duration, I'll be unlocking those seats automatically. And that time duration in the BookMyShow application is 7 to 8 minutes, as you can see over here. Okay. And this is the issue which one of the BookMyShow user was facing. So over here, that user selected some seat and went to the payment page. But that user did not pay the bill for some time duration, probably greater than 8 minutes. Okay. Then after the TTL, he clicked on the pay button. So once he clicked on the pay button, he was getting one error message that it is already booked. Now the reply by the BookMyShow is probably someone else has booked those seats because you have already exceeded the 8-minute timer, right? So I have also implemented this particular scenario in my code. So we'll see the code in the code section. But before that, let's see the class diagram to understand the entire flow. This is the class diagram for the BookMyShow application. Over here, we'll try to understand the entire flow for the creation of the booking and the confirmation of the booking. But before that, let's check out each and every class so that we understand the entities present in this class diagram. So let's start with the models which are present over here. So let's start with the theater. So the theater would be having these 3 attributes, that is ID, name, and the screens which are present in the theater. So instead of having list of screen, I have used map. Why? Because I want to fetch the screens more efficiently, right? That's the reason why I have used map. And over here we have screens, right? That's the reason why we have has a relationship between theater and the screen. So screen would be having the ID and the seats. So again, there is one has a relationship between screen and the seat. Currently in our system, we have 2 types of seat. First is regular seat, second is recliner seat. And since we want to make this seat component extensible, I have created one abstract seat class where all the common attributes would be present and all the unique things of a specific seat would be present into their respective classes, either regular seat or the recliner seat. And in future, if I want to add a premium or VIP seat, I can just create one class and extend that from the seat. Okay. So these were the seats. Now for the movie class, we would be having the ID the title of the movie, and the duration in minutes for that movie, right? And there is one more class called as show. So each and every show would be having the ID, the movie which would be played in that show, the start and end time of that show, and also the place where this show would be played, that is the theater and the screen in which the show would be played, right? So these were the models. Now let's check out the payment component, which is this. So for the payment component, I've used strategy design pattern because I want to have different algorithms in this pay function. So whatever the user will give the input, I have to change the algorithm. If the user selects UPI payment, then this pay function would act as the UPI payment method, right? And if the user selects card payment, then this pay function would be acting like card payment method. So that's the reason why I have used the strategy design pattern over here. And I've also used factory design pattern so that I can create this concrete strategies based on the user input, right? And another reason for using the factory design pattern is we will have one centralized if else logic. If we don't create this factory class, we have to write this if else logic in the client class, and that would violate the solid principle. So that's the reason why we have created this factory class where we would be having that centralized if else logic. Now we also have this lock provider component. Over here we have 4 main functions which would be implemented by in-memory lock provider or the Redis lock provider. And in future we can have different types of lock providers as well. So let's try to understand these 4 functions first. So the first function is try lock. So this function will be locking a specific key for this much time duration. Okay. Now what is this key? I will be explaining that in the code. So we would be basically locking this key for this much time duration, and if we are successful, then we'll return true, else we'll return false, indicating that we were unsuccessful in locking that particular key. The unlock key function will basically unlock that particular key. And is lock expired will check whether the lock is expired on this key or not. If it is expired, then we'll return true, else we'll return false. And is locked by will check whether the lock which is present on this key is owned by this user or not. We need this function for confirming the booking, because when we would be pressing on the pay button, that time we have to check whether we are the owner of that lock or not, right? In order to prevent the scenario which I showed you few minutes back, right? So this was the lock provider component, and this is the booking service class. The 2 main functions in this service is create booking and confirm booking. So when the user selects some seat and clicks on the proceed button, at that time create booking function would be called. And when the user clicks on the pay button, at that time confirm booking function would be called. Okay. And we also have this booking repo. So if you are not aware about the repository layer, then let me explain this in very brief. So the repository is basically a class where you would be having the CRUD operations. CRUD operations as in saving the booking, getting the booking, deleting the booking, or updating the booking. So all this CRUD operation would be performed on some database, right? So in the LLD, you won't be having the actual database. Instead, you will be having the in-memory database like a hash map. So over here, I am using the hash map as my database. And this booking repository will have the CRUD operations. So when I would be creating the booking, at that time, I would be interacting with the booking repo in order to save that booking into the booking database. Okay. And we also have this booking class. So this booking class has several metadata like booking ID, the ID of the show for which the booking was created, the ID of the user, who has booked this particular booking, the ID of the seats, and the status of the booking. So status can be of 4 types. Created. So when you would be clicking on the proceed button, at that time the status would be in created phase. And when you are successful in paying the bill, at that time the status would be confirmed. And if the payment fails, at that time the status would be failed. And we would also have one cancelled status. And we also have this payment type. So user will select one payment, right? UPI payment or card payment. So accordingly, we would be having the payment type. And this amount represents the total price of all the seats which you have selected. Okay. So I hope now you understood each and every classes. So now let's understand the entire flow. So this is the client who would be selecting some seats, and after that he would be pressing the proceed button. So when he presses the proceed button, at that time create booking function of this booking service would be called. Now this booking service will interact with the lock provider in order to lock those seats. Okay. Once those seats are locked, we would be creating the booking using this booking repository layer, right? And we would be saving that booking into the booking database. All right. So this was the flow for the creation of the booking. Now regarding the confirmation of the booking, again, the client would click on the pay button. At that time, this confirm booking function would be called. This confirm booking function will first validate whether the lock is expired or not. And if it is not expired, we have to also check whether the lock belongs to the current user or not. And after that, we would be paying the total amount using the payment type which user has selected, right? So this is the entire flow for the creation and the confirmation of the booking. Now regarding the creation of these objects, what the admin can do is admin can utilize the service and the repository layer of those objects. So for example, movie would be having the movie service and the movie repository. Show would be having the show service and the show repository. So all these services and the repositories can be used by the admin. Okay. So I hope now the entire class diagram and the flow is well understood. So now let's check out the output first before moving to the code. This is the main class. Over here, I've created some repository objects. Then I've also created the lock provider. So currently I'm using in-memory lock provider. Further, I have created services which would be used to perform some CRUD operations like creating the theater and adding the screen in a specific theater and also adding the seat in a specific screen. Okay. Some of the seats would be regular seat which would charge 150 rupees and some other would be recliner seat which would charge 300 rupees. Right. And then using the movie service, I would be creating one movie named Interstellar, which has a time duration of 120 minutes. Further, I would be creating the show using the show service, and this show would be played into the screen 1 of the theater 1, and this is that movie, right? And the start time of this show is 6:30 p.m. All right. So now that we are ready with all the objects, let's see 4 demos. The first demo is whenever a user selects a specific movie by the movie name, that user should be able to see all the shows for that movie. Okay, so this is demo 1. In the demo 2, one user, that is user 1, would first select some seats and click on the proceed button. That is, he will call this create booking function. So this function would be basically locking these seats. Okay. And finally, this user would be selecting the card payment method in order to pay for those seats. Right. So this is the demo 2. Now in the demo 3, we will be seeing the concurrency part. So over here, 2 different users will try to book overlapping seats simultaneously. So what is happening is there are 2 users. First is user 2 and second is user 3. Both of them would select some seats. So this user 2 has selected seat number 3 and 4 and user 3 has selected seat number 4 and 5. So you can see that seat number 4 is overlapping, right? So I've handled that part as well. That is, only one of this user would be successful in creating the booking. The other user will fail, right? So in that case, this message would be printed. Now I am not concerned which user would be failed. Either user 2 can be failed or user 3 can be failed. What I am concerned is only one of them should be successful in creating the booking, that is in locking the seats, right? Now coming to the demo 4, which says that the lock should be expired after the TTL. So currently I have taken TTL as 5 seconds instead of 8 minutes so that I can show you the output quickly. Okay. So over here, first the user 4 will come and select seat number 6 and seat number 7, and that user will proceed to the payment page. So basically these seats would be locked by this user, right? But that user will not pay for that seat for 6 seconds. All right. It means that those seats would be again available for the booking for other users because TTL has exceeded. Hence the lock has expired. All right. So after 6 seconds, user 5 would come and try to lock the same seats, and that user would be successful in locking that seat. Okay. After that, user 4 will click on the pay button. Remember that user 4 is already on the payment page. Okay, so user 4 clicks on the pay button using the UPI payment option. But the thing is, user 4's payment would be failed. Why? Because now the lock is not owned by the user 4. It is owned by the user 5. Alright. And this is the same scenario which I was talking in the starting of the video in the requirement gathering part, right? And finally, the user 5 will click on the pay button and that user would be successful in paying. All right. So now let's check out the output. So first let the demo 4 be completed. Okay. So let's start with the demo 1. So in the demo 1, we would be listing all the shows based on the name of the movie, right? So we selected the Interstellar movie. So all the shows where this is the movie are listed over here. Currently, only one show is there in our system, which is related to that movie. And this show will have all the details like the theater in which this show would be played and the screen in which this show would be played, right? Now in the demo 2, one user tries to book the seat. So first that user would select some seats and click on the proceed button. So when that user clicks on the proceed button, the booking would be created. And when the user is on the payment page, he will be selecting one of the payment type. So over here, the user has selected card payment method. So he will be paying through the card. So 150 would be deducted accordingly. And finally, the booking would be confirmed from the created state. Okay. And in the demo 3, two users would try to book the seats and some of the seats would be overlapping, right? So in that case, only one of the users should be successful in creating the booking. So as you can see, only one user is successful in creating the booking and the other user failed to create the booking. Why? Because there was one seat which was temporarily unavailable. So even if one seat is overlapping, the entire booking is failed. So the remaining seat will also not be locked because of one overlapping seat. Okay. And the user who was successful in creating the booking will proceed to pay. So he will choose one of the payment method and finally the amount would be deducted, right? Now coming to the demo 4, which showcases the lock expiry after TTL. So over here, user 4 selected some seats and created the booking, right? He went to the payment page, but he did not click on the pay button, right? Currently he is on payment page, but he has not clicked the payment button. So after TTL, so after 5 seconds, users 5 will basically try to select the same seat and click on the proceed button, and he will be successful in locking those seat, right? And then the user 4 will click on the pay button. Okay, but the user 4 will get this message, that is, all the seats are unavailable because those seats are currently locked by user 5, because the lock which was held by user 4 has been expired, and now the owner of that lock is user 5. Okay, so user 5 will then click on the pay button and he will successfully pay the bill, right? So I hope now you understood the output. So now let's check out the code. Hi guys, there's a small note. If you are liking my LLD series and want me to also make videos on system design, then please like and share my LLD videos so that I get motivated. So these are the classes available in our BookMyShow system. So firstly, don't get overwhelmed by seeing lots of classes present over here, because one thing is all of these classes has only few lines of codes. So it is very easier to code them up. So let's see all of them one by one. Let's start with the enums. So we have this 4 enums. The first one is the booking status. So the booking status would be in the created phase if the user selects the seat and goes to the payment page. Okay. And when the user pays for the seat, that time it would be in confirmed state. And if that payment fails, then it would go into the failed phase. And we also have this cancelled phase if the user decides to cancel the booking. The second enum is the payment type. So currently our system has 2 different payment methods. The first one is card and second is UPI. So we have these 2 types of payment enums. Then we have this seat status. Now the seat can be either available, locked or booked. Similarly, there are 2 different types of seat. First one is regular and the second one is recliner. And you can add more types in future if you want to add. Now let's check out the models: theater, show, seat, regular seat, recliner seat, screen, movie, and booking. So the first one is theater. So each and every theater would be having these 3 attributes which I have already explained in the class diagram, right? ID, name, and the screens. And we can add the screen into this hash map using this add screen function, and we can get the specific screen using the get screen function. Now going to the screen class. So each and every screen would be having the ID and the seats present in that screen. And we can add the seat using the add seat function and get the seats using the get seat function. Now coming to the seat class. So this is the abstract seat class which has the ID and the price associated with it. And there are 2 different types of seats present in our system. First is regular seat, which will return the type as the regular. And the second one is recliner seat, which will return the type as the recliner. And all the unique attributes related to that seat would be present in this particular class over here. Okay. Now, then we have this show class. So each and every show would have all the details regarding the location and what will be played in that show, right? So we have the movie which is going to be played into this show, and the exact location, that is the theater and the screen in which this show would be played. We also have the start and the end time of this show. All right. Now coming to the movie. So each and every movie would be having the ID, the name of that movie, and the duration in minutes for which this movie would be played, right? Now coming to the booking class. So each and every booking would be having several IDs like booking ID, the ID of user who has booked, the ID of the show which was booked, the IDs of the seat, and the status of the booking. So initially when I create the object, this status would be in created phase. The payment type which user has selected to pay, for example UPI or card, and the total amount of all the seats which user has selected. All right. So we have gone through the models as well. Now let's check out the repositories and services. So repositories are the classes where you write the CRUD functions like saving and getting. Okay, you can add deleting and updating as well if you want, but in our system, we only need save and get. So this is the in-memory database where all the movies would be stored. And these are the CRUD functions which will be performed on that in-memory database. So this was the movie repository. Similarly, we have the show repository and theater repository. So all the code is similar in this classes. So if I show you one of them, then in the save function, you will just put this theater into this in-memory database. And for the get function, you'll just return the theater with this particular ID. All right. And the service layer will have the corresponding business logic. So for example, the movie service has this logic. Okay. So in the create movie function, you would be first creating the movie, and once this movie has been created, you can save that into the database with the help of this save function present in the movie repository, right? And you can also throw some exceptions if you want over here, because this is the business layer, right? Similarly, we have this get movie function as well. Now in the show, apart from the create show and the get show, we also have this get shows by movie title. So over here, you'll just iterate through all the shows present in the show database, and you'll filter those shows who has this particular title, right? And finally, we'll convert that into the list. So by the way, this is stream. So we have to convert that into some data structure, right? So that's the reason why I've converted that to list, and I'm returning this list of shows to the end user once the end user types a specific name of the movie. Okay. So this is the service layer for the movie service, show service, and the theater service. Now coming to the payment strategy, we have a payment strategy interface with a function called as pay. So this function takes the booking object. Now I'm passing the booking object because this object has all the details, like the amount which user has to pay and all the details of the users as well, right? So that's the reason why I pass the booking object as the input. You can also pass the booking ID if you want. So if you pass the booking ID, then you have to fetch the booking object from the database in the implementation of this pay function. So we have two different types of payment strategies. First one is UPI payment strategy. Over there, you will pay through the UPI, and after that, if it is successful, then you will return through, as you return false. But currently, for the demo purpose, I am just logging and returning as through. All right. And similar thing is repeated in the card payment strategy. Now the only 4 classes left are booking service and this lock providers. So let's see the lock provider first. So we have this lock provider interface, which has this 4 functions to be implemented. This will be either implemented by in-memory lock provider or Redis lock provider. But currently in our code, we'll be using this in-memory lock provider. Now let's check out the in-memory lock provider. So in the in-memory lock provider, we will be implementing these 4 functions. The first one is try lock, which basically locks this particular key for this much time duration. And this key is nothing but the concatenation of show ID and the seat ID which user has selected. Okay. So we would be locking that particular key. So by the way, we are using the concurrent hash map for the locks. Okay. This is not the ordinary hash map. It's concurrent hash map. Why? Because I want to avoid the race condition while updating a specific key, right? So this is the key which I have already explained, and this is the expiry object. Now each and every expiry object would have 2 details. The first one is the deadline when this key would be expired, and the second one is the owner of that particular lock. Okay, so now let's see this try lock function. So over here we are first calculating the current time in milliseconds, and we are then creating the expiry object. So in the expiry object, the deadline would be the current time in millisecond plus the total time to leave, which is 5 seconds in our case. Okay, because we took 5 seconds as the TTL for the demo purpose, right? And after that, we also have the user ID. So this is the user ID who would be owning that lock. Okay, then after that, I am checking whether this key is present in the concurrent map or not, and if it is not present, or if it is present, then I'm checking the deadline. If the deadline is less than the current time, it means that the lock has been expired, or the lock is not there if it is null. So in those situation, I am updating the expiry object, which you can see, else I am not touching the expiry object. All right, and finally I'm comparing that with the new expiry object. So if this particular statement returns true, it means that we are successful in locking, else we are not successful. So we'll return true or false according to that. Then we have this unlock function, which would just remove the key from the concurrent map. Then there is this function called as isLockExpired. So over here, we'll first get the expiry object, and we'll first check whether it is null or not. If it is not null, in that case, we'll check the deadline. So the deadline for the lock to be expired should be less than the current time in milliseconds, right? So I'll be checking that. And after that, there is one more function called as isLockedBy. So over here, I'll check whether the owner of this lock is this user or not. All right. So these were the 4 functions. Now, one more thing that I want to highlight is this sweeper instance of the schedule executor service. Now, what will this do? This will basically perform this operation after every 1 minute. Okay. So the operation says that we have to go through this concurrent map and remove all the expired keys, right? So in simpler words, this sweeper is going to remove all the expired locks after every 1 minute. All right. So I hope you understood this point. Now, the last class remaining is the booking service. So let's check out that. So this is the booking service class, which will interact with the lock provider and the booking repo. So in the BookMyShow, the TTL was 8 minutes, right? So it was 8 into 60 into 1000, right? But right now I am just setting it to 5 seconds. All right, because for the demo purpose. Now these are the 2 functions that we discussed in the class diagram. The first one is create function, which would create the booking. So for that, we need to lock the seats. So let's say 2 users simultaneously tries to lock the seats, the 2 same seat. So these are the 2 users. They both will come over here and go into this for loop simultaneously, right? And they would compute the same key, because show ID and the seat ID are same for both of the user. Then in that case, this would come over here, and they would simultaneously call this try lock function. But the thing we discussed about this function was only one of them would be successful, right? Because this is performed on the concurrent map. So that's the reason why only one of them would be successful. Let's say T2 is successful. So T2 comes over here, and T1 goes into this false state. So T2 will directly return sit not available exception, right? So it will go out of this function only directly. All right. So this basically allows only one thread to be successful if the seats are overlapping. All right. Now, once one of the thread is successful in locking all those seats, that thread would basically compute the total price of those seats using this for loop. And after that, we would be creating the booking object and then saving that booking object into the booking database using this CRUD function available in the repository layer, right? And then finally we'll return the booking object. All right. So this was the create booking function. Now coming to the confirm booking. So over here, we'll first check whether the status of the booking is in created phase or not. If it is not in created phase, we cannot confirm it, right? So first we'll check this. And after that, if it is in created phase, we'll again validate whether the lock is still there and the lock is owned by the current user who is calling this confirm booking function. So we would iterate through all the seats again and we would generate the key and check whether the lock is expired or not. So if the lock is expired or the lock is not owned by current user, in this two situation, we would throw the exception. That is, seat is not available. It means either the lock is not there with me or lock was there but it is expired, right? And finally, based on the payment type which the current user selected, we would be creating the strategy using the factory design pattern, right? And after that, we would be calling the pay function of that strategy. And finally, we would unlock all those seats which were locked, right? Because now they are permanently unavailable. Okay. And finally, we will convert the booking status to confirmed status from the created status, right? So this was the confirm booking function. So we have seen all the classes which are present in this application. So now let's check out some scenarios in order to understand that why we should not use in-memory lock provider in our production application. So basically your backend application would be deployed on this EC2 instance, right? So the end user who wants to book the seat S1 will interact with the application in this server and create a lock on that particular seat, right? So this was the scenario which we were working on till now. But let's assume that your application became very popular and the traffic on your application increased a lot, right? So for obvious reason, you have to scale the servers horizontally. So let's say you created server 1 and server 2 and you deployed your application on both of those server. Okay. And now there are two users who wants to book the seat S1. All right. So what will happen is this user 1 will first interact with the load balancer and load balancer can redirect this user 1 to any one of the server. So let's assume that this load balancer redirected this user to server 1. So on this server, we will create a lock on the seat S1, right? So this user 1 has successfully created a lock on seat S1 in the server 1. And this lock which is created is in-memory lock. Okay, it means that this lock is not present in the server 2. It is only present in the server 1, right? So now let's assume that user 2 also wants the same seat. So it will interact with the load balancer and load balancer can redirect this user to any one of the server, right? So let's say it redirected the user to the server 2. Now the user 2 sees that the seat is not locked, which is a problem, right? Because it is already locked by user 1. Although it is on different server, but this would cause problem because user 1 is also getting seat S1 and user 2 is also getting seat S1 at the end of the day, right? So that's the problem. Now, in order to solve this problem, we have introduced the distributed lock provider, for example, Redis. So what will happen is user 1 wants to book a seat S1. So it will interact with the load balancer. Load balancer will redirect that user to one of the server. Let's say it redirects the user to server 1. Now server 1 will lock the seat S1. Okay. And that lock would be present on the Redis. Okay. Over here. Now user 2 will come. User 2 wants to lock the same seat. So it will interact with the load balancer. Load balancer will redirect to one of the servers. So let's say it redirected this user to server 2. Now this server 2 will check whether there is a lock on the seat S1. So it will interact with the Redis and Redis will tell, yes, there is a lock on seat S1. So this server 2 will deny this user to create a lock on that seat, right? So we have successfully solved that particular problem because now we are using the distributed lock provider like Redis. Okay. So I hope now you have understood entire BookMyShow LLD. If you did, then please like the video and share this video with your friends. Thanks for watching.